Got it? Perfect. So what we're going to learn about this week is multiplying a whole number by a decimal, okay? But before we start, I want to talk about some terms that I know you guys have seen before, okay? Who has seen these words before? Decimal, product, factor, and partial product. Yeah, you should all know what some of these are. So what I want you to do is you're going to talk with your table mates for about 30 seconds. And you're going to talk about what you know about each one of these words, okay? Ready? Go.
Decimal.
What do you know? No. There you go. Good. There. What's a decimal? Yeah, good. Good job. What do you think a product is? You got it. You got it. There you go. What do you think X is? Then you have Alright, here we go. Let's get back up here. Alright, who said, what did someone tell me what they said about decimals? What is a decimal? And not that little circle thing that's next to a number. Hunter, what do you think a decimal is?
Like a period.
Over your mouth. Yes, okay.
Like what you're putting into the syllable.
Yes, kind of like a period, but we're talking about what a decimal is in math. But I like your answer. Yeah, Rachel.
Like if you were to write $1.
Okay, I see what you're saying. All right, Xavier.
A decimal is what comes before a whole number. When you get a decimal when you divide like 1 divided by 10.
Yeah, I see what you're saying. Okay, what about a factor? Factor, Delilah.
It's something it's like the number you multiply.
Good. Okay, so if that's what factor means, what's a product? If we have sums and addition, Mackenzie, what's a product? The answer to a what kind of problem? Multiplication. Yes, definitely. Okay, now, if we know that about product, what's a partial product? What, Kristen? Part of the product. Yeah, okay, so we're going to learn more about partial products tomorrow. I'm going to teach you one method for multiplying decimals today. We're going to learn 2 more tomorrow. That way we can choose which one and say, this strategy makes most sense to me, so I'm going to use this one. That's why I'm going to teach you 3, but I'm only teaching you 1 today, okay? Partial product is one of those. So a decimal is a number containing a decimal point, and it separates a whole from a fractional place. So we have tenths, hundredths, thousands. So obviously a decimal would be like 6 tenths. We don't say point, 6 tenths. Okay? Now a factor. That is the numbers being multiplied. So 6 times 4 is 24. The factors are 6 and 4. And then that's where the product comes from. That's the product. So we have the factors and the product would be the answer, which is 24. And then partial products, that's what we're going to learn about. So today we're going to learn the bunk method. And now this is something that Miss Gilpin spent all night thinking of. But before I tell you my story that I created, we're going to try this problem right here so that we can see the relationship between addition and multiplication. So what we're going to do is a tower of blocks has 3 layers, okay? Each layer has 8 blocks. You're going to write an addition and multiplication equation to show the total number of blocks. So you can draw this out if you don't remember how to do this, but we did this previously. I don't know when you did it, but I know you've done it. So you're going to try to figure out how to write a multiplication problem and an addition showing how many total blocks there are if it has 3 layers in a box. Okay, open your book to page 309. It's going to be like for the front of your book. Yep, it's right there. It's like on like the first page. 309. 309. Okay, you're going to use that. Yes, you did get one. Rachel. I remember writing her name.
Rachel, yours is probably up front.
Yeah, go check yours. See if it's where you sit in homeroom. Okay, so what you're going to do is write down an equation for this to try to figure out the answers. If we have 8 blocks and 3 layers, figure out what you need to do. Is it in there? Haha. Yeah.
Yes.
Think about it. It's okay if you don't know. We're just trying it out. Good. Good. Yes, Xavier. Let me give you a sharpened one to use for right now. Yeah. Just hold on to that one and we'll put that one back in the front. Alright, so right here you're writing out an equation for this problem. Yes. You did get it right. Good job. Yes. You're just writing 2 equations. One that is adding, one that is multiplying. So draw it out. If you have 8 blocks, so you can draw 8 blocks and then 3 of those because it's 3 layers. So you're drawing 8 blocks 3 times. What is it? Then write down that equation. There you go. 8 times 3 is, that's your multiplication equation. Now you gotta do one for adding. Hey, you need to finish your test today, so you need to come back after lunch and finish your test. Okay. Allison. Alright, who's got it?
I think I said 8.
You think so? You confused Ben? Yeah. No. Yeah. Okay, we're going to talk about it because this is stumping some of you. So, we have 8. I want orange. No, I want green. We have 8 blocks. Okay? There are 3 layers of blocks. So, if you're imagining that this is 1 layer of 8 blocks, this is 2 layers of 8 blocks, this is 3 layers of 8 blocks. I'm just adding 8 plus 8 plus 8. Okay? The answer is 24. Now, instead of just adding 8 plus 8 plus 8, I can just multiply. 8 times 3 is 24. So, a multiplication equation for this would be 8 times 3, and then the addition one would be 8 plus 8 plus 8. Really, all this problem is trying to show you is that multiplication is repeated addition. I'm adding 8, I'm adding 8, I'm adding 8. Whereas multiplying, you just do 8 times 3. So that's all that this is trying to show you. So we're going to remember this when it comes to multiplying decimals, because tomorrow we're going to practice multiplying with models, and it's pretty much using repeated addition. So that's why they're showing you this. Okay, but now it's story time. Are you ready for a story?
Yeah.
All right.
Colin loved this.
I stayed up all night thinking about, how am I going to teach this to these kids? Well, then it hit me. Slumber parties. That's how I'm going to do it. Who's ever been to a slumber party? Yeah, they're so much fun. You smack somebody with a pillow. It's a great time. Okay, so what we're going to do is I'm going to read this problem and then I'm going to tell you my story. So you better listen. Oh, there's someone at the door. You're interrupting story time. It's okay. All right, you ready? So Margot has 6 square tiles that are equal size. Each side of the tile is 8/10 inches long. Margot places all the tiles in a row with the sides touching as shown, because this is the problem in your book. How long is the row of tiles? So what it is asking us to do is multiply 6 and 8/10. Now, here's where the story begins, because 8/10 is the same as what in a fraction? I'm pretty much saying it, 8/10. 8/10. So when we have a decimal and it's in the 10th place, it's the same as saying, this is the 10th place, 8/10. If I had 4/10, what would that be? 4/10. Okay, so anything in the 10th place is the same thing as putting it over 10. Do you get that part? Because this is very important to our story. Okay, so here's what happened. 6, or we gotta turn around, 8 and 8/10. 6, 8, and 10, we're having a slumber party, okay? So, we have 6, he's the whole number, he's this big guy, he's like, hey, I'm here for the slumber party. I'm like, oh, come inside. Okay, so 6, 8, and 10, they're so tired, they've been doing TikToks all night long. They're exhausted from doing all these little dances, okay? They're like, man, we're slumped, we gotta go to bed. So, here's our bunk bed. This fraction line, that's our bunk bed. This is called the bunk method. 8 gets on top, he's in the numerator. Okay, 10 is in the bottom, he's on the bottom bunk, he's about to take a snoozer. Alright, 6 is like, wait a second, 8's on the top bunk, 10's on the bottom bunk, where am I gonna sleep? I don't wanna sleep on this crusty floor, that ain't about to happen. So I was like, hey yo 10, like, can I go stay with, like, can I sleep on the bottom bunk? Can I throw my pillow in there? Stay down there, and he's like, bro, there's no room in the denominator, there's no room down here, you cannot stay. So 8's like, hey, 6, come on up here, we're gonna chill. Okay, so 6 climbs up there, he joins the 8. Now we have 6 and 8 in our numerator, and 10 is selfish little 10. He's sitting down there sleeping by himself in the denominator. Okay, so this is what our problem has happened. We turned 8 into a fraction, and our numerator, or our whole number, joins the numerator. So 6 times 8 is 48. That's them, they're rolling and snoozing all night, kicking each other in their sleep. Okay, they multiplied. Now, after they multiply, they wake up, and the number that joined here is going to climb back out. So our 4 climbs back out. That means he's back down on the side. 8 and 10 are lazy. They're still there. Okay, so we have 4 and 8/10. And that's our answer.
The slumber party.
The bunk method. Okay, now I'm going to do another one just to kind of do it a little quicker.
I like it.
All right, here we go. Bunk method. Lewis has 9 chocolate bars that each weigh 4/10 grams. What is the total weight of the chocolate bars? So it is asking us to multiply 9 times 4/10. What is 4/10 as a fraction? 4/10. Okay, so we erase that, put it over 10. Now, if you don't want to sleep on our whole number, he's like, I ain't sleeping on the ground. So the numerator says, hey, come and join me. So we put him in the top bunk. What's 9 times 4? 36. Okay, the top multiplies, the bottom stays the same, and our number in the front climbs back out of bed. So we have 3 and 6/10, which is the same thing as 3 and 6/10. You get it?
Yeah.
Okay, let's try another one. I'm going to change the numbers, and then you guys are going to try one in the try it box on your thingy. Okay, so change 9 to 6, and change 4 to, okay, we'll do 6/10. So we have 6 times 6/10. Now, if you get confused, our steps are up here. Put the decimal over 10, put the whole number in the numerator, multiply the 2 numbers on top, and just write it as a decimal. So try this one by yourself. Think about what you need to do. Show your work on your paper and then give me thumbs. Good. Now put your 6 over 10. You're going to change this to a fraction. So put over 10. Yeah, you just put a line, a fraction line, and then a 10 underneath it. So now we're going to put our whole number on our numerator because it wants to sleep on the top bunk. So we're doing 6 times 6 on the top. Good. And what is 6 times 6? Good. Put 36 over 10. Good. Now our first number, he joined, but now he's going to climb back out. So 3. Good. And 6 tenths. So decimal 6. Good. Good job, Barrett. Yes.
Right?
I'm going to teach you multiple methods. It's not the only way to do it. So if there's another way that makes sense, that's okay. You can. We're doing both. Yeah. Yeah. You did good. What? Yeah. Good. All right. Who's got it? Give me those. You got it? Giovanni, does it make sense? You got it? Yeah? Okay, good. All right, let's do it. What do I do first? Braxton, what do I do first? I put what?
Take the 15 and 10. Down there and make the 10.
Yep, all right. I have 6 tenths. Okay. Now, where does our whole number go? It joins what, Ava? It joins it. Yep. So we are multiplying 6 times 6, which is
36.
okay. We slide our 10 over, and our first number comes back down. So we have 3 and 6 tenths, which is the same as saying what? 3 and 6 tenths. All right, so make sure your answer is in a decimal form. Do we need to do another one?
No.
I agree. We're going to do a trickier one. Well, y'all said this is so easy. So let's try it. All right, let's try one. Okay. We're going to try... Ooh, yeah. What number is that? I don't know. Hold on. Okay. This is not in the tenths place. It is in the hundredths place. So instead of putting it over 10, we're going to put it over 100. But we still do the exact same thing. You're still going to multiply the top, but it's over 100. So you got to remember your place value rules. Okay? Go ahead and try this one on your own. If you have questions, raise your hand. I don't want you to struggle by yourself. You do. That's my PowerPoint? Good. If Allison doesn't get it, then explain it. I made it. I use a thing called Canva. That's over 100. I said over 100. Okay, if you get it and your neighbor's still confused, turn to your neighbor, ask them if they need help, and then explain to them how you got your answer. How you doing, Barrett? 7 times 3 is 7, 14, 21. So our answers, we're not adding, we're multiplying. 21 over 100. Yes, let me see what's wrong. Okay. That's good. Remember, it's in the hundredths place, so nothing comes down because if we backwards check, 21 is not bigger than 100. No. Okay. Yeah. No. Okay. Hold on. All right, look up here. Eyes up here. Eyes up here. So you're getting tricked by the hundredths place. Okay. What's 3 times 7? 21. Okay. So now we have 21 over 100. But if this was 10, yeah, we'd bring down our 2. But is 100 bigger than 21?
Yeah.
No, so if we backwards check, then it would be just 21 hundredths because we're just writing this as a decimal, okay? Remember how we backwards check?
I get it.
You can do that with this. Huh? Okay, let's do another one. Yeah, it gets tricky when it's in the hundredths place. Okay, let's do 2 times 800. Listen.
Xavier.
2 times 800. We're gonna put this over 100. Okay? 2 times 8 is 16. So we have 16. Oh, I just gave it away. We have 16 over 100. Now, if this was 10, there would be a whole number, but it's not. So it's just 16 hundredths, okay? 16 hundredths. That's our answer. Now, if this was just 8 tenths, then it would just be over 10. And that's when you would bring down the decimal. But look, we brought the decimal over because it's in the hundredths place. Yes, Rachel? If it's over 10. Yes. Yes. When it's in the hundreds, there's probably not going to be a whole number. Yes.
There's something wrong with that.
Why? Oh, the 0 in front.
Hey, guys. Think about this, I just noticed this earlier. If it's an improper fraction, it's gonna have a whole number.
Yes.
If it's not an improper fraction, it's just gonna be a decimal.
And remember, improper fractions are where the number's bigger on top. So we have why did I put it up? If we had like 11 over 10, this is improper. But if we had 9 over 10, that's fine.
Patrick.
No, you're good. Okay. We want another one? Hold on. Actually, let's do this first. Think in your head. Take a moment. On a scale of 1 to 5, how well could I teach this to my neighbor? So think in your head. All right, if I'm a 1, that means Miss Gilpin, I ain't know nothing about what you just told me. If it's a 5, it's like, oh yeah, I can explain that to someone and tell them exactly what to do. Think in your head. All right, show me your fingers. What is it?
It is.
I see some 5s, lots of 5s, some 3s and 2s. That's okay. 4's good. Good. Okay. That means we're gonna do one more. We're gonna do one. I'm gonna give you 2 problems. One where it's in the tens place, one where it's in the hundreds place. Okay. Do 6. I don't want to do 6. Do 4 times 5 tenths. And I'll put this 0 here for 100 because he likes to see the 0. Okay, and then when you're finished that one, do 4 times 5 hundredths. Okay? Do both of these. Okay, remember, put your decimal over 10 if it's in the tenths place, over 100 if it's in the hundredths place. Multiply the top. You got it. Yeah. And then your answer's a whole number. It's okay for our answers to be a whole number. It's okay if our answer's a whole number. 0 over 10 is just 0. So it's just the whole number. Alright, who did I trick?
No one.
Alright, I'm going to do the first one really quick. You put it over 10 because it's in the 10th place. Yeah. Alright, 4 times 5 is 20. 20 over 10, that's just the same thing as 2. Think about it. 10 goes into 20 2 times, so our answer is 2.
Got it.
Alright, let's look at this one. I put this one over the hundredths place because it's in the hundredths place. 4 times 5 is 20. We have 20 over 100, which is the same as saying 20 hundredths or 2 tenths.
Oh.
So this is still 2 tenths or 20 hundredths, or yeah.
I was right.
Does this make sense? Yeah? Yeah. Okay, let's do some practice problems. I'm gonna hand you out an independent sheet. You are supposed to ask questions along the way. I don't want you to struggle alone. I'm telling you. Don't sit there and be confused. Okay, go ahead, put your name on this paper. I just want to see what you guys know. Show your work. All the things.
I'm getting
That's okay. Some things that might be easy to you could be hard to other people, and some things that are hard to you could be easy to others. So,
Let someone
all right, get started. Get started. For a piece of paper. Oh wait. What? That's okay. Because I have this leg in my leg, so I'm trained for doing the same thing. I was sitting and I was
All right, get going, get going.
yeah, still there. No, I know. And I'm fine.
Oh,
It's
that's
been what,
get going.
10 years? Oh. Yep. I was.
What were you recording for?